of biology. I'll probably give it another minute or two to see who else is going to join, and then we'll dive right on in. I guess first things first, I would want us to start with a little change of pace of yesterday. Start with a nice little icebreaker just to get us all feeling a little bit more like comfortable, like using the chat to make sure that the chat is working properly. Say first things first is what would be either your favorite hobby outside of now studying for the MCAT, or my all-time favorite icebreaker, which is roses, thorns, or sexy gardener. Um, Share with me either a rose of this week, so that's something that you loved, a thorn, something that wasn't so great, or sexy gardener, which is going to be something that you're looking forward to, something that you're excited to happen in the next coming week. Get things going. For me, my favorite hobby, at least while I was studying for the MCAT, my favorite thing to do when I wasn't studying for the MCAT was actually, let me think, because I can't think of anything else I did beyond study for the MCAT when I studied for the MCAT. I did take up yoga. I did start taking up yoga. I did it very sporadically. I did it maybe once a week. That was probably the only free time I had. And then I'll share with you guys a rose, thorn, and sexy gardener. So to provide an example, a rose, something that I loved this week was that I finally submitted my application to medical school. So that made me happy. Um, Thorn, it took me quite a while to submit my application to medical school. Thank you guys. And sexy gardener, something I'm looking forward to is um Juneteenth. Looking forward to celebrating Juneteenth this upcoming Monday. And even more so, I'm looking forward to Saturday when we'll all be in person together and reviewing content. I think that will be even more fun because then you can't ignore me because I'll be right in front of your face. You
Do you want us to share like one of all three, or can we just pick one of the?
can just pick one. If you want to share all three, go ahead, but you can just pick one.
I'll do a sexy gardener. I'm going to a glass blowing class on Sunday, and I'm just really excited because it seems like it's going to be so much fun.
No, that seems really fun. Do you like make like vases? Like what do you do?
Yeah, so
Or
I
do you
make
just make
whatever I want. Yeah, so like each item costs a different amount, and I think I'm gonna make a flower because the flower looks really pretty.
That sounds like a fun time. I'm gonna add that to my summer to-do list.
I'll send you the link.
Please. What about anybody else? Any roses, thorns, sexy gardeners, or hobbies?
I can share a sexy gardener. My parents are coming to visit this weekend, which means
Ooh,
basically I'll get food out of them, which is great.
yeah. Yeah. Every time I would visit home, one thing I could always count on was being fed, which would really counter my diet at Hopkins.
Yeah, my mom asked me to tell her what food I want her to bring. So yay.
That's amazing. And in the chat, Jessica said, I like to take walks around campus. Yes, I think it's a nice break from studying and just enjoy the sunshine. I love that. Actually, I graduated in December, and when I first graduated and before I started working, all I did was walk around my neighborhood because I could not think of anything else to do. And it did so much for my mental health. So I think that's really nice. I enjoy kayaking from Alexa. I've actually never kayaked a day in my life, but I know what it is and it seems super cool. So that's really cool. I'm getting a TV today for my apartment. Congratulations. TVs are expensive and I hope you watch a lot of Netflix on there and really enjoy it whenever you're taking breaks from studying. Okay, that was great. I've learned a little bit about almost everyone, and that makes me really happy. And I'm glad to see everyone can use the chat. I would say next things I want to do before we jump into our immune system review is kind of like backpedal, because I feel like yesterday I didn't properly introduce myself and also explain like why I'm even here. So again, my name is Angel. I'm one of the Jump Test MCAT consultants. I took the MCAT May 2022. I took it actually during my finals week, right at the end of spring semester, and I studied for the majority of spring semester. I scored a 521, and my score distribution was a 130 in Chem Phys, a 129 in Cars, then a 131 in Biochem and Psych Soc. Another reason why I'm here is because I actually do in fact tutor and teach for the MCAT outside of Jump. So after about 6 months after I took the MCAT, so this like January, I started tutoring and teaching the MCAT over at Blueprint Test Prep. So I've had some experience tutoring and teaching the MCAT, and that's another reason why these lesson packets seem so in-depth, is because they are effective. They are proved to be actually like actually emulate the MCAT and to actually help you learn the content that you need for the MCAT. So if you do have time, please do make sure to look through the packets, look through the answer key through them. And ideally, what I would like is for you guys to look through both nervous system and the immune system one prior to Saturday, because I'm going to assume that you guys have gone through them. Another few things about me outside of MCAT and outside of tutoring and teaching for the MCAT is that I currently work as a research technologist over in the Department of Pediatric Neurosurgery at Johns Hopkins Hospital. So that's why like I started with the nervous system, because I really do love the brain and the nervous system. I studied neuroscience at Hopkins as well. I got a question in the chat: how did you balance classes with MCAT studying? So fortunately for me, when I was picking my classes, I tailored them to the MCAT. So all of my classes were like STEM classes. So when I was studying for my classes, I was also kind of studying for the MCAT. I think I only had one class that wasn't as MCAT focused. So I was taking, I would say most ones that corresponded the most were going to be genetics and behavioral endocrinology. And behavioral endocrinology was really helpful because the MCAT loves tying systems into different functions. So behavioral endocrinology looked at how the endocrine system played into behavior. And we also got to touch a lot on how the endocrine system and the nervous system interacted. And that's going to be a really big component of the MCAT, which is seeing how everything kind of fits together in the body, how everything is kind of intertwined and working with one another. But okay, that's enough about me. If you have any more questions, please just drop them in the chat. You can either direct message me, say it to everyone, I'll answer it no matter like what we're in the middle of, or I'll answer it at the end if it's a complete like segue out, but your question will get answered. So now we'll transition into the immune system. And another thing I'll do slightly differently today is that I will actually drop the link to the packet in the chat so that you guys can follow along simultaneously with me as soon as I pull it up on my iPad. Mm. Okay, let me know if you guys are able to open that. Either just give a thumbs up or perfect. Okay, so we are good to go. Okay. So the immune system, the title of today's lesson is going to be a reunion with the immune system. And this is going to be basically a just crash course on the immune system. And the most important thing when it comes to the immune system, or the reason why we're even looking at the immune system right now, is because one, it is extraordinarily high yield on the MCAT, but outside of that, it is really important in our functions as doctors. We are looking to help and to heal patients. The immune system is going to be there fighting to essentially prevent us from going to the doctor. A lot of times when we end up at the doctor, it's because something went wrong with this protective system, the system that is going to resist us getting sick. So we have a few learning objectives. Our first learning objective is going to be describe the role of the cells that comprise the immune system, and to also look at the different components of the immune system. So the immune system is broken down into typically two different parts. You have your innate immune system and you have your adaptive immune system. How does everyone feel about the innate and adaptive immune system? What are some things that we know about the innate and adaptive immunity? Do we know nothing at all? What are some things that distinguish them from one another? Why is there a separation? Yes, innate is non-specific. And adaptive is specific. And that's mainly going to be our T cells and B cells. So another huge component of our innate immune system in that non-specific realm is going to be our barrier immunity. And the main thing with the barrier immunity is it's going to be our outside protective factor. So our skin is a huge part of barrier immunity. Our tears, mucus, even our GI tract, stomach acid, those are all going to be things that just protect against pathogens from entering just by forming a barrier against them. Another big type of barrier that I feel like a lot of people, or that people tend to not think about, is going to be that blood-brain barrier. As you know, I am a neuroscience major. I will tie everything back to the brain as long as I can. And that blood-brain barrier is going to protect against a lot of not only pathogens, but also a lot of chemicals and things within the body from entering the brain and disrupting that kind of like perfect ecosystem that it has within there. That's another big reason why a lot of brain infections or even like brain cancers are very hard to treat, and a big part of like developing drugs when dealing with these like brain diseases is just figuring out how can we get the drug to cross the blood-brain barrier? Will it even be able to cross the blood-brain barrier? And with those T cells and B cells kind of switching over to adaptive immunity, our T cells is going to be like our fighter cells. That's how I like to think about them. And our B cells are going to be our cells that kind of like memorize what like happened. Remember the fight. They're going to be the recorder. They're going to be the camcorder with the fight. And a lot of big thing is with the B cells are going to be your memory B cells. There are memory T cells as well, but big thing with B cells is going to be remembering what happened, and that B cells produce antibodies, which segues perfectly into the next point. What are some things we know about antibodies? Do we understand variable region, constant region? How do antibodies function? Okay, no problem. So with the structure of antibodies, so the main function of antibodies is antibodies are going to bind to an antigen. So a lot of times for those of us who do research or who have done research, you know that there are a lot of like experiments that play on this antibody antigen relationship. So this is when you have like an antibody for a protein of interest. That's going to be that antigen. The antibody will bind to it, like in your immunohistochemistry. When you're trying to look at something under the microscope, you'll have an antibody that is specific to a protein, and the antibody will bind to that antigen. They kind of have a very loving relationship, antibodies and antigens. And the way that antibodies work is antibodies are composed of two heavy and two light chains. And these heavy chains are going to be these thick chains right here. And then the light chains are going to be these two smaller regions. And they are linked together by disulfide bonds. So next week, we'll get into biochemistry. And biggest thing I want everyone to take away from like disulfide bonds is that whenever you hear disulfide bonds, you need to start thinking of the amino acid cysteine. But okay, back to our antibodies. So they have these two heavy chains, two light chains linked together by these disulfide bonds. There is going to be a variable region. It's going to be this part right here. And then you have a constant region. It's going to be this part right here. our variable region is going to have that antigen binding site. That is going to be where it changes and how we have that antibody specificity for an antigen. That constant region, as the name suggests, it will be conserved across the majority of antibodies. And it can be recognized by a type of, by these FC receptors, which are going to be on phagocytes. And this is going to be for receptor mediated phagocytosis. And that's going to be almost like a directed phagocytosis. Then with antibody specificity, once again, that's going to mainly be that the fact that antibodies are going to be extraordinarily specific. A lot of times an antibody will only bind to one to one antigen. It's a really good thing to also like add in here. Again, if people have done research, especially molecular or cellular biological research, would have heard of maybe like polyclonal versus monoclonal antibodies, whereas polyclonal antibodies can bind to multiple regions on an antigen, whereas a monoclonal antibody will only bind to one specific region on that antigen. So they can be extraordinarily specific for not only the antigen of interest, but also for a part on that antigen. And this epitope is going to be the part that is recognized. For specificity. And then some functions of the antibodies in the immune system are going to be the complement system. So the complement system is a part of the immune system, and it's basically a protein cascade that ultimately results in an osmotic lysis of a cell. But the biggest thing to think of when you hear complement system is that it involves antibodies, and that it is a protein cascade. That causes cell lysis. If you look up complement system, you will see thousands upon thousands of articles and papers taking a extraordinarily deep dive into it because it is significantly more detailed than that. However, for the MCAT, all you really need to know is protein cascade, cell lysis, antibodies. Opsonization, that's what's going to tag proteins for receptor mediated phagocytosis. Oh no, it's pathogens. which we'll abbreviate as RMP. Yes, so the heavy chains and light chains, all you really need to know is those are just the things that compose the antibody. And they just look like that. That's why a lot of times when you see pictures of antibodies, they're in these like wide shapes. They are like peptide chains. So antibodies are proteins. And they're linked together. So this is the linkage. So the heavy and light chains are linked together by disulfide bonds. Does that help to clarify it, or is there, okay. And then last role of antibodies, the last main role of antibodies in immunity is going to be inactivation. So antibodies can kind of cluster on pathogens and on their surface proteins and inactivate them by rendering it non-infectious. Okay, before going into MHC1, MHC2, how does that feel? How do we feel about antibodies? Do they make sense? Do we understand their importance? Okay, that's good. Just always remember antibodies, they have a very strong B sound. Antibodies, B cells make antibodies. Sorry. Then lastly is going to be our MHC1 and MHC2. Oh, sorry. SERPRO is surface proteins. So MHC1, MHC2, these are major histocompatibility complexes. These are antigens that are found on our own cells. And the way I like to always think about it is that we're always going, so this is mainly going to be for T cells. A lot of times when we think of MHC1 and MHC2, this is going to be T cells, though our natural killer cells also play a role in them. But with the recognition and the binding, a nice mnemonic I like to remember for remembering which T cells are going to recognize and bind to MHC1 versus which T cells are going to recognize and bind to MHC2 is that the total product will be 8. So with MHC1, we have our CD8 plus killer T cell. 8 times 1 equals 8. And with MHC2, it will CD4 plus helper T cells. 4 times 2 equals 8. And MHC1 is going to be expressed on all nucleated cells in the body, and is basically just like a way that the cell can be recognized. So like almost like an ID badge for a cell is what MHC1 is going to be. And that's why it's mainly going to be our CD8 T cells that are going to recognize them, or our natural killer cells. So our natural killer cells are going to be a part of our innate immune system, and they are going to only be able to recognize self cells. So a lot of times when we hear natural killer cells, we also hear like cancer in the same conversation, because in a lot of like immunotherapy for cancer that is like up on the rise, they are using these CD8 T cells and these natural killer cells because they can actually attack self cells. So attack self cells without initiating an autoimmune response, because when they're overactive, then we have autoimmunity issues. MHC2 is going to be presented by antigen presenting cells, or APCs. And that's going to mainly be our dendritic cells and macrophages. And a lot of mainly our antigen presenting cells are going to be ones that can phagocytose cells and then express antigens, surface antigens afterwards, that almost like indicate, oh, I need to go, or oh, I've swallowed something that's bad inside of our body. We need to get ready. We need to prepare to fight because something's going wrong. So MHC1, self cells, ID badge, APCs, phagocytes. How does that feel? How's a quick rundown on T cells and major histocompatibility complexes?
This is a basic question, but you would say that MHC2s, that's part of the the adaptive immunity system?
Yes. So
Uh.
both MHC1 and 2 are mainly going to be in adaptive immune system, because we're going to have our CD8 T cells in MHC1. MHC2 will be very similar to MHC1, where there's going to be an innate immunity component where we have our phagocytes, which are innate, and then a very large adaptive immune component where we have our CD4 T cells. But in MHC1, our innate component is going to be our natural killer cells. Does that answer your question? Okay, perfect. So is everyone else good on MHC1 and 2, which T cells are product is always 8 rule? Like, are we good to move on to practice questions? Thumbs up, yes. Number 9, no. I guess first we can do a cell overview, and then we can do some practice questions, because I have mentioned at least 5 different immune cells without actually diving into which ones are which. So leukocytes those are going to be just a general term for all of our white blood cells. Lymphocytes are going to be those two like big adaptive immune cells and our natural killer cells. Granulocytes are going to be those cells that have these small little granules that essentially they help to destroy pathogens whenever they phagocytose them or whenever they are attacking them. And they tend to do that by these granules are able to cause this reactive oxidative species damage. So oxidative damage to further destroy the bacteria or virus. And those granulocytes are going to be all of those cells that end in phils. So your neutrophils, your basophils, and your eosinophils. Neutrophils, that's going to be our like almost immediate response to any type of bacterial infection or any type of immune stimuli. And it's going to be our most abundant white blood cell. They compose about 70% of our white blood cells. The next most abundant white blood cell, or a slightly smaller, actually a significantly smaller amount, is going to be eosinophils. And those are mainly going to respond to parasitic infections. When I first learned about eosinophils, I was always able to remember them because I was told that they are for parasitic infections and parasitic worms. And the worms really stuck out to me because of how gross they were. These are going to be about 4% of our white blood cells. And then basophils are going to be our least common white blood cell, and they are less than 1% of our white blood cells. And their main function is going to be they release histamine and heparin. Histamine causes dilation of blood vessels. Heparin causes to decrease blood coagulation. So that dilation of blood vessels, our blood vessels are becoming wider, and then we're decreasing coagulation or blood clotting. So it's really going to be like it's going to raise our blood pressure. It's going to increase the amount of blood, and it's going to decrease our clotting. And then our last group is monocytes, which will differentiate into macrophages or macrophages, I've also heard, and dendritic cells. Dendritic cells are another type of phagocyte. And a lot of times when you hear about dendritic cells, you tend to hear them in when talking about immunity in the skin. That was when I first heard about dendritic cells. Okay. In terms of granulocytes, those are going to be part of our innate immune system. And again, that's going to be our neutrophils, eosinophils, basophils, but also mast cells. So the biggest thing to remember is that basophils and mast cells are basically the same, but whereas like basophils are going to be in the blood, because all of these are blood cells, mast cells are going to be like in tissue. For neutrophils, eosinophils, basophils, do we want to do another quick review on that, or are we good? Like, does everyone remember all of the things I said about them? Or would we prefer if I like wrote them out right here? Thumbs up for can move on. Number 9 in the chat for please write it out. Okay, 3 nines. Okay, so neutrophils, again, those are going to be our main white blood cell and our first responder. You can kind of think of them as the EMTs of the immune system. And they are phagocytes, and they're going to fight against bacterial and fungal infections. Eosinophils, those are going to be the ones that are going to respond to our parasitic infections. And they are next most common. And another big thing is going to be allergic reactions. And there are next most common granulocyte, making up about 4%. And then basophils are going to be our rarest white blood cell, and they are going to release histamine, and heparin, which will ultimately increase blood pressure. This histamine is going to result in dilation. You have more space for more blood to flow. Heparin is going to be an anticoagulant. Our blood will be thinner. It will not clot as readily. It will almost, I like to think of it as deactivating our platelets. And then mast cells are going to be same as basal, but in tissues. Okay. How does that feel? Good on granulocytes? Okay. Moving on to monocytes. Monocytes are also going to be a part of our innate immune system. And here we have our dendritic and our macrophages. Our dendritic cells are very important because they tend to bridge the gap between our innate and adaptive immune system. This is because they are APC. So they're going to present antigens to T cells, and specifically, they are going to present them to activate CD4 T cells. So they're going to So when thinking of dendritic cells, also think CD4 plus T helper cells. And again, dendritic cells, I always like to think of it, whenever I think of it, I think about the skin, and that's because dendritic cells tend to be located in parts of our external, parts of the body that come in contact with the external environment. And then macrophages, a nice way of like remembering how macrophages or macrophages function is if you say garbage instead of, or garbage, and then you have macrophage is macrophages, macrophages, garbages. It functions essentially as a non-specific garbage can of the body. It's just kind of going to engulf and throw away whatever should not be there. And also non-specifically. Macrophages, garbages. How do you feel about monocytes? Okay, perfect. And then before we get into some practice questions, we have lastly our, oh, that's wrong. Let's just say lymphocytes. Sorry about that. We have lastly our lymphocytes, which are going to be, again, our B cells, our T cells, and our natural killer cells. So B cells and T cells interact with one another, specifically helper T cells and B cells interact with with one another. And biggest thing to remember is that helper T cells are going to activate B cells in order to become plasma cells and then release antibodies. And when we're talking about B cells, we're going to call that humoral. Humoral immunity. And that's mainly in reference to the function of antibodies. So humoral immunity tends to refer to the immune effects of antibodies and how antibodies work. Another big thing, so B cells, remember antibodies. And almost capitalizing on that B cells are going to be made and mature in the bone marrow. And again, just a quick summary about B cells. Whenever they are stimulated by binding to an antigen or by an antigen wanting to bind by them, they will get a signal from a T cell. That antigen will bind, and then they'll become a plasma cell. They'll be activated. Then they'll be able to release those antibodies to do that, to function in humoral immunity and to do the three main roles of antibodies, which is going to be that complement COI, complement system, opsonization, inactivation, or OIC, opsonization, inactivation, complement system, whatever really sticks with you. That's what I say makes the best type of mnemonic or abbreviation. Then quickly going through T cells and helper cells, T cells, contrasting B cells. They are produced in the bone marrow, but they mature in thymus. Helper T cells, that's going to be those CD4 plus and responding to MHC2. And then remembering total is always going to be 8. And they're going to respond to those antigen presenting cells, our main antigen presenting cell, dendritic cells, and they activate B cells. Cytotoxic, or your T killer cells, those are going to be that CD8 plus MHC1. Again, total is always 8. They are going to recognize and destroy cells that are presenting abnormal MHC class 1 proteins. And they will induce apoptosis. And our regulatory T cells are going to be our anti-inflammatory cells, and they are going to tell the immune system to calm down. And they present a combination of CD4 plus and CD25 plus. And then natural killer cells, those are going to be our innate immune cells that are also recognized are self cells. They just aren't as antigen, they aren't antigen specific, but they will respond to these MHC1 as well. And again, abnormal self cells. And then just remember that they are innate immunity. How does that feel? Do we get T cells? Do we get lymphocytes? Yes, no, kind of confused, went too fast. Thumbs up, ready for practice questions. Number 9, I want you to explain what you just said all over again. Okay. Question number 1. Monocytes move from the systemic circulatory system into general connective tissues, where they differentiate into what phagocytic cell type? So I guess first thing here that we should be thinking about are, what are monocytes? What cells can monocytes become? What do they differentiate into? Yes, C is correct, macrophages. So monocytes differentiate into dendritic cells and macrophages. And even if we didn't know whether dendritic cells or macrophages were in connective tissues, like which one was in connective tissues, we see here that the only thing that a monocyte, our only monocyte product available here is macrophage. So we can automatically know that that's the correct answer. And also knowing that T cells and B cells are going to be a part of our adaptive immune system, we can automatically rule those out. And then we're left with neutrophil and macrophage. Okay, that was good. Number 2, suppose an individual is exposed to a bacterial pathogen and develops symptoms of infection. This individual successfully recovers from the infection without the need for medical intervention. But 6 months later, he is exposed to the exact same pathogen. Compared to the immune response during the first exposure, the immune response to the second exposure will develop. A, more rapidly and be greater in magnitude. B, more rapidly but similar magnitude. C, in a similar amount of time, but will be greater in magnitude. Or D, in a similar amount of time and will be similar in magnitude. So I'm seeing a lot of B's in the chat. So the first part of B is absolutely correct. More rapidly. We know that it will be more rapidly, so we can automatically eliminate C and D. Because remembering that we have those memory B cells, you know that we're going to act a lot quicker this time around. So now it's just, will it be similar in magnitude? Will it be greater in magnitude? So the best thing to do here is to kind of just like think about what would be the best use of our immune system in this situation. If it's seeing something that it recognizes and it knows that it can take out. So the first time around, it's going to see something, it's going to be confused about it. It needs to have the time to figure out which antibodies are going to be, to make those antigen specific antibodies to be activated by the T helper cells to initiate the entire immune response. Is going to take a lot longer in the first time around. And the wave of attack or the type of attack won't be extraordinarily strong because your immune system is still learning what is actually going to work. Is this actually going to be effective, or are we just going to be sick and feel sick for a long time? Versus the second time around when we see it, we already have those memory we already have those memory B cells, we have the antibodies present, we know how we're going to attack it. So would we attack the exact same way, or would we attack significantly stronger, knowing that our exact response is going to be, the response that we're going to give is going to be absolutely effective? Yes, then our answer is going to be A. And it's mainly going to be because that would be a better use of our immune system that will keep us sick and down for a lot shorter period of a time because we are going faster and at a higher magnitude. So that shortened sickness period that you feel if you get the same cold again isn't because you just started responding faster to the cold, but because your body recognized the cold, your body was able to attack the cold a lot stronger and a lot more effectively. We are at time. Do we want to do these last two questions, or would you guys prefer to just continue this on your own and then come ready on Saturday for us to do a more of a dive into this packet and the nervous system packet? Last two, please. Okay. For number 3, which of the following immune cells will act most immediately against a bacterial pathogen following infection of a naive host? A, CD4 plus helper T cells, B, CD8 plus cytotoxic T cells, C, plasma B cells, or D, neutrophils? Yes, D. So one thing all A, B, and C have in common is these are going to be in our adaptive immune response, which we already know comes after our innate immune response. And also seeing how similar A, B, and C are, I'm already questioning, will those be the right answer? The only one that is significantly different is going to be D. So that's another strategy that tends to come into play on the MCAT when you don't really know what the answer is. Which one stands out? Which one is different from the rest? Yes, neutrophils. Just remembering, neutrophils are our EMTs, our first responders, the firefighters of the immune system. We can think of our adaptive immune cells almost as like the doctors in the hospital. They have their specialties, they have their strongest fields, they are going to be very effective and they are going to solve the problem, but you only get to the doctors if you absolutely need to. And before you get to the doctors, most of the times you go through those EMTs. Okay, number 4, a certain infected cell expresses MHC1. Binding of a CD8 plus T cell to this complex results in A, production of antibodies by the T cell, B, destruction of the infected cell by the T cell, C, destruction of the infected cell by macrophages following activation of the complement system, or D, lysis of the T cell. What are we thinking for number 4? First things we should ask ourselves is, what is a CD8 plus T cell? Those are going to be our cytotoxic T cells. Yes, B is the correct answer. That's perfect. So you can rule out A, production of antibodies by the T cell. That's not what the T cell does. Antibodies, those are going to be our B cells. Destruction of the infected cell by macrophages following activation of the complement system. Regardless of the rest of that, the first chunk of the sentence, we see complement system. We know that that's going to be in our oik/koi of our antibodies, B cells. We know this is not something that our T cells are doing. Lysis of the T cell, that would defeat the purpose if we're trying to fight against something and the T cell lysed, then it would not be effective. So B, destruction of the infected cell by the T cell. So remember, T cells are going to do apoptosis. They will initiate a cell suicide programming within the infected cell. They will tell them to end their life, and they will. But that is all for today, our quick run into the immune system. How do we feel about the immune system? Do we feel like we understand more about it? Is anyone interested in specializing in rheumatology now? What are our feelings about today's lesson? Overwhelmed, underwhelmed, enough whelmed? Better, but still about it. That's understandable. On Saturday, we can go more into it, but the immune system generally is going to be one of the harder things to study for. Generally, by most medical students, immunology is the least favorite subject because it is oddly in depth. And the more you look into it, the more you find there is to it. But luckily for the MCAT, it does not go that deep into it. And the most you need to understand about the most basic part of the immune system is going to be, that will be on the MCAT, will be what we reviewed today. And also for some recommendations, the way I best learned the immune system and a big way I studied for the MCAT was I would always listen to podcasts. So there's a bunch of MCAT podcasts on the immune system. A one that I really like is going to be this MCAT Go podcast by, I think his name is Sam Smith, not the singer. And then there's another one by Blueprint, not just because I work there, but the Blueprint MCAT podcast is also really good. They also go through and in-depthly explain questions. I used it a lot in my studying, and it was really good in the beginning when I was learning how the MCAT asks questions and trying to figure out what I should look for when studying for the MCAT and doing practice questions. So podcasts will be your best friend. Also YouTube videos. Just make sure you try to specify MCAT. Khan Academy will also be a really good resource for that. And I believe this will also be posted to the Canvas site, but just in case, I will also drop the answer key for this in the chat as a special thank you for staying the extra 10 minutes while I talked more about your body fighting infections. But other than that, does anyone have any last minute questions, comments, or concerns? Or do you just want to wait and bombard me on Saturday? Either is fine with me. You're welcome. Okay. Bye, everyone. See you this weekend.